The question says which of the following is lesser acceptable resonating structure of azide ion. This is what we have, azide ion. Okay. We can draw the structure. We have nitrogen, three nitrogens are there, triple bond nitrogen is there. Okay. This nitrogen has lone pairs. In this case, we have three lone pairs are there. Okay, because always keep in mind, nitrogen general forms how many bond? 3 bond. So its valence is satisfied. It does not carry any positive and negative charge. But if the nitrogen is forming more than 3 bond, it will always carry positive charge. It has positive charges there. And if the nitrogen is forming less than 3 bond, it will carry negative charge. It is supposed to carry negative charge. This nitrogen is forming one extra bond, then it is carrying positive charge. But this nitrogen is forming two less bond, then it is supposed to carry -2 charge. Okay. -1 charge is equal to 1 lone pair, we can mention 1 lone pair. Okay. -2 charge will be equal to what? 2 lone pairs. So we mention 1 lone pair. This is another lone pair. This is the one lone pair which does not participate in the bond formation for this nitrogen is there. So in general, these 2 lone pairs are representing what? -2 is there. -2. This is what? -2, and it is what? +1. Then overall charge over this azide ion will be what? -1. -2 plus 1 is equal to -1. That's why -1, -1 is given here. Okay. Now pay attention here when this electron density moves this side, because positive charge is there. So when this electron density, a wave of electron is coming, as a result this electron density will move this side. So what kind of structure we are getting? In this case, nitrogen is there. When this electron density is moving this side, obviously will create double bond. So double bond is there. Nitrogen is there, its positive charge is gone. But this electron density is moving this side, again we have double bond is there, and this is nitrogen is there. Now we decide positive and negative charge. This nitrogen is forming how many bond? 4 bond, 1 extra bond. Okay, 1 extra bond. It can form 3 bond, but it is forming extra bond. Then it will carry 1 positive charge. Nitrogen forming more than 3 bond will always carry positive charge. Nitrogen forming less than 3 bond will always carry negative charge. Okay. This nitrogen is forming less than 3 bond, then it will carry negative charge. It is also forming less than 3 bond, it is carrying negative charge. So you can see the overall negative charge is what? -2. Overall positive charge is what? +1. Then for this azide ion, overall the charge will be -1. -2 plus 1 is equal to -1. Then again we can carry out resonance. Okay. So if this electron density is moving this side, so obviously it will create triple bond. In case if this electron density is moving this side, then it will cause triple bond. Okay. So triple bond can here also, it can be here also, part of resonating structure. This form is also possible, this form is also possible, and one more form is possible. This triple bond can be here also, and single bond will come here also, part of resonating structure. So you can see double bond is there. This form is possible, this form is possible. Single bond, triple bond is there. This form is possible. Single bond, triple bond is there. This form is possible, and overall negative charge for this azide ion is what? -1. But this is what a cyclic part we are getting, cyclic. In this case, too much repulsion will be there. You might have learned in organic chemistry, 5-membered or 6-membered rings are more stable than 3-membered or 4-membered. Why? Because there will be repulsion between the atoms, between the lone pair or bond pair. So in this case, this is a cyclic ring we have, and these lone pairs are very nearby. So they are causing repulsion. Due to the repulsion, there will be high instability in this system. High instability. We are talking about resonance, means stability will be increasing. Stability is supposed to increase, but in this case stability is decreasing due to highly unstabilized system, because too much repulsion is there. Closed system is there, and these all the electron densities are near to each other, causing repulsion and leading to instability. This is a highly unstable system, and which is opposite to the resonating structure. We have option C is correct. If you like this video, please share and subscribe to the channel.